Hi and welcome. I'm Gary Hope, a Program Manager on the Azure Cosmos DB team. In today's session, we're going to introduce you to a couple of the ways to better understand your Cosmos DB configuration and the application workload that you're running on it. With those insights, we'll help you identify several opportunities to optimize your Cosmos DB cost. Who better to talk about that than a couple of the folks on the front lines, out there helping our customers optimize their environments every day. I'm joined today by Emmanuel, a Cosmos DB Global Black Belt, working with many of our customers across Europe.
Hello, everybody.
And Thomas, a Cloud Solution Architect and Technical Lead for Cosmos DB Customer Success.
Hi, everybody.
Let me start with a quick reminder on the basics of how Cosmos DB is built, as this will form the basis for much of our conversation and exploration today. We'll also explore this much needed and less understood NoSQL pricing format for Cosmos DB. A Cosmos DB account contains multiple databases and containers. The bill for the account is the sum of the cost of all of the databases and containers within it. The simplest way to think about the cost of a Cosmos DB account at the next level is that it is made up of database operations, which we'll drill into in some detail shortly, and the storage cost, billed on an hourly basis, being the total number of gigabytes used for all of your data, the JSON documents you stored in your database, the space used by the indexes to index them, and the storage used to back these up. Thus, the most obvious way of savings is to eliminate databases or containers that no longer need it. You will be amazed how many of these creep into existence unnoticed. Carefully evaluating your backup retention requirements for each of the accounts and the number of backups you retained allows you to manage these costs as well. That gives you your total price. There's one other aspect associated with Cosmos DB, given that it is a globally distributed database, and that is global replication cost considerations. This is the number of regions that you configure your account for. You have a choice on how many of and which regions your data is replicated to, and the cost of the operations and storage cost is multiplied by the number of regions that you have. So let's drill into exactly what these operations costs are and how they accrue to dollar costs. All operations are measured in terms of the underlying resource consumption, CPU, memory, and I/O, that is utilized. And we abstract these away into what we call request units. These request units are there for every operation that you perform against your database. Every operation that you perform has a charge in request units, whether it's an insert, a read, a query, or a delete. The charge for an operation is highly predictable. If you insert, update, or delete a document of a certain size, it will always have the same charge. If you run a query over the same data, it will always have the same charge. If you understand the operations your application is using or needs, it is very easy to calculate the total required charge on a per-time basis. The operations performed by your application is measured in request units, or RU. Typically, these don't translate directly into dollar costs unless you're using Cosmos DB serverless. I'll touch on that briefly a little later. Typically, you'll provision throughput for your workload. Cosmos DB is provision throughput is the number of request units that you have available in any 1 second. If you provision, you will have a bucket of, let's say, 100 request units per second. You will have 100 request units available for every second for your operations to use from. If your usage of the provision throughput is exceeded for that second, you will have used up all of those RU in that bucket in that second. Your application will then be rate limited, and these throttled operations will need to automatically be retried in the following second when the bucket has been filled again. Provision throughput is billed per hour, so you will be charged for the amount of provision throughput during that hour, the maximum amount of throughput provisioned during that hour. So, if the line on this graph represents the throughput of the application needs or the throughput you're assuming, in this case, a fairly stable, predictable hour-by-hour basis throughput, you would need to provision throughput above this level in order to ensure that the requests are not going to be throttled. If your workload changes from hour to hour, typical of workloads that run only during office hours or only on weekends, you would want to avoid having provision throughput during those times where it's unused. You can manually provision throughput at the level you choose and can adjust it at any time using either the portal, the CLI, or code and automation to do so. Most workloads, however, don't look like this. They look much more like this. How would you choose a provision throughput for a workload that looks like this? For this reason, Cosmos DB introduced autoscale provision throughput, where you can choose the maximum throughput you need. And Cosmos DB will adjust the amount that you build based on the usage you have in that hour. Remember, you build per hour for the provision throughput that you need. Cosmos DB will automatically and instantly adjust to the amount of the amount you build based on the usage that you have between that max that you've set and 10% of it. There's one last aspect to consider, and that's the billing rate. Cosmos DB autoscale provision throughput is 50% more expensive than the rate at which you provision standard throughput. So you need to choose between autoscale and manual provision throughput. Given that most workloads are not consistent and predictable on an hour-by-hour basis, autoscale provision throughput will provide you with the most cost-efficient option and should typically be the default choice, despite the fact that it is a slightly higher billing rate. Only if you have a highly consistent workload or a predictable periodic workload would manual provision throughput be your best choice. And remember, you can always choose between manual and autoscale and switch between them at any time you like. With that, let me hand over to Thomas, who will guide us through the exploration of the real Cosmos DB accounts that you work on every day.
Thanks, Gary. A first step in any optimization exercise is to understand what it is I actually have. As Gary mentioned in the introduction, the build for Cosmos DB is primarily driven by throughput, storage, and region configurations. Let me start by showing where throughput-related information can be found. The overview page for your Cosmos DB account provides an easy way to see a list of all databases and all collections within these databases, along with their provision throughput. It also allows for seeing which collections are part of databases utilizing shared database throughput and which collections are leveraging the auto-scaling mode, as can be seen by the max throughput in the bracket. If a throughput for a particular collection, such as the food collection in my demo, appears too high, I can navigate to the Data Explorer pane. Let me switch over here. I can navigate to the Data Explorer pane, locate that particular collection, click on Settings, and reconfigure the throughput. I will also immediately be able to see what the impact will be on my Cosmos DB build. But in order to decide which collections might need a throughput adjustment, I need to first find what the utilization is. And the best place to find such information is the Insights pane. Insights pane provides me with a quick overview of the most important operational metrics for my Cosmos DB account. If I filter for the same collection and same database that I've just shown, that is the food collection, I can see that the utilization barely hovers above the zero for most of the time, suggesting scale down is possible and appropriate. So this was for the throughput part. For storage, which is the second of the three main components of Azure Cosmos DB build, I can also leverage the Insights pane. If I unselect the collection and the database, and I switch over to the Storage tab up here, I can see a list of all my collections and how much data and index they are consuming. along with the number of documents stored within each and every one of them. Another component that contributes to the storage cost is my backup configurations. Backups are configured on an account level, not on a collection level. To find what my backup configuration is, I need to navigate to the Backup and Restore tab. Here I can see the number of snapshots of data that I'm retaining, 2 in my example, and for how long they are retained. This number 2 snapshots is driven or determined by the frequency with which backups are taken and for how long they are retained. By default, Cosmos DB provides first 2 snapshots for free, but if I were to configure, for instance, hourly backups and I preserve them for a week, that would mean 168 snapshots of data. The cost for that would add up quickly. With that, we have covered the storage part. And now for the last main component, the regions. Much like backups, regions are also configured on the account level, and the configuration can be found on the Replicate Data Globally pane. Here I can see which regions are configured for my Cosmos DB account, in my case, France Central and West Europe, and whether availability zones are enabled. In this case, they are not. I can also see whether the multi-region rights feature, which effectively turns every region into a primary region, has been enabled. Now, this feature doubles the overall cost of my Cosmos DB account, so it is important to evaluate whether I actually need to enable it. As every additional region that I add to my configuration multiplies the cost, and by that I mean 2 regions are double the price of 1 region, and 3 regions are triple the price of 1 region, and so forth. It is important to ensure that I utilize all of my regions to the fullest potential. Let's switch back to the Insights pane and find out what my utilization is across my 2 regions. Let me first increase the time span to say 3 days, so we get a bit more data in the charts. And now these pre-built charts contain different breakdowns, but they do not show breakdown by regions. So in order to see what my utilization is across the regions, I have to open this total requests chart in a dedicated window, where I have the ability to add additional filters and apply splitting. So in this case, I will apply splitting by region, and I can see that I have performed about 65 million database operations against my account, and only 400 of those requests have gone to the West Europe region, suggesting that it's essentially unutilized. Now, while that might suggest that removing West Europe could be a way to save on cost, caution needs to be taken to understand the application uptime requirements, as West Europe might be used for high availability purposes as a hot standby. Staying within the same view, I can change the splitting by region to splitting by operation type. And this will provide me with a breakdown of how many reads, how many writes, patches, and other kinds of operations I performed, and help me better understand my workload. Now, this is the view I can get from the metrics. But if I'm trying to investigate something on a lower granularity than the metrics can provide, as they always aggregate all the requests, to at least a 1-minute window. And if I'm trying to investigate a single request, what I need to do is I need to enable logging. So the way to do that is by navigating to diagnostic settings. I'll click on Not Now for here, and I'll have to add a new new diagnostic setting to start capturing those logs. So the two important pieces here are to enable data plane requests and query runtime statistics. And you would want to send those into a log analytics workspace. Once those two steps, these are one-time configurations, have been completed, the logs will start to flow. I'll now transition over to the logs tab over here, and let's investigate if I have any very expensive queries. So we offer a couple of pre-canned queries to get you started, and one of them is top queries by consumed request units. I can simply click on run. It will pre-populate this query for me, so I don't have to type it out. I'll reclaim some real estate on the screen, and I get an output which is showing which of the queries are the most expensive, along with the query text. So here at the end, I'm getting the number of times this query was run in the evaluation period, which is 24 hours. What was the total consumed request units, and what was the average request unit per execution? Let's assume I have identified that one of my queries is expensive. Now I'll hand it over to Emmanuel to show you how you can optimize an expensive query.
Thanks a lot. Thanks a lot, Thomas, and thanks for the explanation. So now let me review your query. So for me, you have a query on partition demo user review v1 with my collection here, and you have this query select star from C where username, product, and genes and rating, from product and rating. So when I execute this query, I will run this query and I will have 10 documents. I can go through the portal to the query state and identify exactly what will the request charge, what is the request charge, how many results you have. So here you have an amount of information that you can see and check. One important thing is to review. Okay, do you use index? What is the index type? Because by default in Cosmos DB, as you know, your index policy is a wildcard index. So that means every field are one on their own index. One things and one first solutions that you can do when you want to do this is, can you maybe optimize the index and find some information and to retrieve and have the same query with less consuming. So I have executed this query, and you can see here the value of 92. Now let me execute this query here and take the same, but I will have here inside an indexing demo, I have made a copy of user review, and I will explain later how I done this. And you can see in the settings, I have created a composite index on username, product, and rating. If you remember on your query, this is exactly the where clause of your, this is exactly the where clause of your query. And when I execute this query, I have, of course, the same information, same number. And if I go to query stat, you can see it will reduce a lot. Due to the multiple filter you have, using a composite query can help you to reduce the cost of your query. And this is one of the first and important things. How to identify which composite index I can use, or what is a potential index? Do I use my index? And a lot of customers ask me this question in general, and they ask me, hey, Emmanuel, how can we do this? How can you help me? What we have done recently is in the SDK, we have introduced something named populate index matrix. And here I have made a very small applications. And when I run these applications, it's a .NET run. If I use, for example, on food collections, the collections that Thomas showed you before, with a select, with multiple where, here, it will give you some information around the index utilization, index information, and here, it suggests some potential composite index to help you. So this is a great thing. You can help and identify some missing index in case of, and some potential index that can help you to reduce the cost of your query. Another things, a lot of customers ask me, okay, Emmanuel, but here it's just select. In your application, you have some insert, some update. So does by default indexing, for example, have overcast if you made an insert or not? So here I have already two collection, one with default index, so all is indexed by default, and one here where I make a tuning of my index. So I will index only username, product name, and verify. What I have here, I have an applications, and when I launch my application, it will write in the container the same document. If I use a default index policy, the cost is 12.95. If I use a write, the cost will be 6.1 if I use a tuning index policy. So imagine if you have 10,000 documents, how much you can reduce the total consumer request unit. And if you reduce the total consumer request units, of course, you can reduce the cost of your information. It's very important. Now, let's see if you have some other technique or other things that you can do to reduce the total cost of this query. Because, okay, now we have a cost of 8. Maybe we can continue to reduce and having something. There are some concepts very important in Cosmos DB. It's how to scale. How to scale, you scale using partitions. In Cosmos DB, when you work in the settings, you are defining a partition key. What is a partition and what is a partition key, and understand these two concepts. When you define a partition key, you will create some logical partition. That means all the documents that use this field, we have the same ID, will be in the same logical partition. And that will be stored in physical partition. When you begin to set up something, maybe you will create a lot of partitions. For example, if you store more than 50 giga, you will have multiple physical partition, or every time you have more than 10,000 request units, to create some partition. So it's very important. And when you see here the user review, the settings, the partition key is ID. When I go to the query here, do I have ID? No, that means it make a cross-partition query if I have multiple partitions. What I will do here, I will run this query, but this query on the new container who have made a copy. So if I go back to partitions demo, here I have who is the same collection, user review too. And if I check the setting of user review, here it's username. Now, that means I have the partition key in my query. And if I run this query, I go to the query stats, you can see that the request charge is very, very low compared to the first, from 92 to 3.64. So using inside your queries the partitions key is very, very important. Now, how can I see how much partition I have, if the partition are used? Do I have cold partition or cold partition? This is something very important. So you can go in the insight. Okay, and when you go in the insight, you will have multiple informations that will show you. If I go to the throughput here, I can see that I have some request units and see how the request units are charged by partition key. In my case here, I can see that I have 30 partitions, and some partitions are used at 14%, some other at less 11%. Seems that here my workload is good, but I can see in the times for every partition how it's used if I use only here 15 partitions. What it's important to understand that when you decrease the number of request units, it will divide by the number of partitions you have. So that means if I have 1,000 and 2 partitions, that means for each partition I have only 500 request units, and that's something very important to understand. If I had choice about partition, how can I do? How can I correct this? Today we have introduced and launched a new function. This new function is the intra copy container. What does it mean? That means that I can copy one container to another with the same amount of data and changing some information. This is, for example, what I have done to copy here the partition demo user review hand to the partition review index demo, but with changing, for example, here I don't change the partition key, but this is something I can do. I have changing the index policy. And if I go here, I can show you. So we have now inside the CLI some new Azure Cosmos DB query. It's command, it's DTS, and you will copy from one resource group to one other with a resource group. And here you can see I have launched previously the copy of user review to index demo from user review for partition demo. And you can see that it has copied more than 852,000. So with this intra copy container functionality, you can now make a copy and change your partition key if you have made a wrong choice in terms of your partition key. Thanks a lot. Now let's go back to Gary, who will recap the sessions we have present and show you and explain the recap.
So in summary, we hope that in the last couple of minutes, we have provided you with the insights needed to understand what makes up Cosmos DB cost. We had a quick look at the portal and Azure Monitor to help you understand and drill into the characteristics of your Cosmos DB account configuration and your workload that runs on it, looking for those most obvious opportunities to save costs. We had a look at some of the details on optimizing RU cost for specific operations by choosing appropriate indexing policy, and a quick look at how to choose a partition key and how that impacts the query costs, how to tune your queries so that you can optimize taking that into account. And if you need to alter your partition key, we demonstrated how you can use Cosmos DB data transfer service to copy data to a new container with an optimized partition key configuration. Thank you for joining us and look forward to seeing you all soon.